Imagine the moment your landing legs touch Venus. No applause, no wide horizon, just a dull thud under a sky the color of old brass, and a pressure so heavy it feels like the planet is already leaning on your chest. For the first few seconds, nothing explodes. That's the trick. Venus doesn't kill you with fireworks or a single dramatic impact. It kills you with conditions that make survival physically impossible, even if your ship looks intact. The countdown starts the moment you arrive, because the environment is already inside your tolerances. From orbit, Venus looks harmless, even beautiful. A smooth, bright sphere wrapped in glowing clouds, close enough to Earth that people still call it our twin. To the casual observer, twin sounds like comfort, like familiarity. But the closer you get, the more you understand the word is a lie. Venus isn't Earth's sister, waiting to be discovered. It's Earth's face, melted and hardened into something unrecognizable. It looks calm only because the violence is built into the air. The death clock starts with the atmosphere at ground level. The surface sits at about 467 degrees Celsius, with pressure around 93 bars, roughly what you'd feel 900 meters under Earth's ocean. The air is mostly carbon dioxide, about 96.5%, with nitrogen making up most of the rest. This isn't air in the way your body understands it. Down here, carbon dioxide is so compressed it behaves like a supercritical fluid, a dense, hot sea that clings to everything. That matters because it transfers heat efficiently, like the planet is pressing a heated blanket against your hull. On Earth, you can step out of a hot room and cool down. On Venus, the environment is the room, and the walls are everywhere. Day and night don't give you the relief you expect, because the surface stays brutally hot and stable under that heavy atmosphere. Now imagine you crack the hatch. The instant you expose your suit and lungs to that pressure, your body loses. A normal pressure suit is built around a small differential, not 90+ atmospheres pressing inward. If your suit fails, even slightly, you don't get a second chance. Your lungs cannot function in a CO2 ocean, and your blood cannot carry oxygen you can't breathe. Even before heat finishes you, the mechanics of respiration are gone. But pressure is only half the sentence. The temperature is the executioner. At 467 degrees Celsius, Venus is hotter than the melting point of lead. And heat doesn't need hours to ruin you. It only needs a pathway through seals, joints, and cooling lines. Your suit, your valves, your electronics, your pumps are fighting heat that never stops pushing inward. In a dense medium that behaves like a fluid, heat transfer is fast and unforgiving. You don't merely feel hot. You are being cooked from the outside in. This is why 60 seconds is not just a headline. Survival depends on perfect systems, and Venus attacks every system at once. Within a minute, any weak point becomes the point of failure. A gasket softens, a valve sticks, a sensor drifts, a circuit overheats. And once one critical layer fails, the rest follow, because there is no safe ambient world to fall back into. People hear Venus and think acid, and that part is real too. just not the way most imagine it. The clouds above are decks of sulfuric acid droplets, a corrosive ceiling you must pass through on the way down. Even if you survive the descent cleanly, the lower atmosphere still carries reactive trace gases that work on materials and seals. The wind doesn't rescue you either. Near the surface, winds can be slow, but the air is so dense that slow motion still has force. It can push dust and small particles like a sluggish current of hot liquid, and that means abrasion and contamination over time. If you're thinking, then don't step outside, stay inside the lander, you've just invented a longer version of the same death. The lander becomes a pressure cooker sitting inside another pressure cooker. Your life depends on insulation, cooling, and seals that cannot relax for even a moment. We know what Venus does to hardware because we've already thrown machines into it like offerings. Venera 7 in 1970 transmitted for about 23 minutes from the surface after becoming the first spacecraft to land on another planet. It was built to be strong, and Venus still reduced it to a short, fading voice. Venera 13 in 1982 survived 127 minutes on the ground and sent back the color panoramas that still haunt planetary science. That endurance is famous because it's abnormal, not because it's easy. Even our best survival on Venus is measured in minutes and hours, not days. And those landers didn't need breathable air, body temperature, circulation, or nerves that can't tolerate cooking. A human on Venus is not competing with those machines. A human is dramatically more fragile, and the planet is already operating beyond the margins of biology. Then there's the trap people forget. Leaving is harder than arriving. On Earth, rockets fight 1 atmosphere at sea level. On Venus, you're trying to launch from a place with around 92 times Earth's surface pressure, inside a dense CO2 environment that behaves more like a hot fluid than a thin gas. Every engine bell and ignition sequence has to work while being crushed and baked. The thrust you need rises, the fuel you must carry rises, and the vehicle mass rises with it. At the same time, the time you're allowed on the ground collapses because heat is eating your margins every second. Even if you built a launch system strong enough, you still face the thermal problem. You can't fuel a rocket, check systems, troubleshoot, and wait on the pad when the pad is an oven. You would need to land, confirm, and launch on a schedule so tight it borders on fantasy. That is why most serious human concepts for Venus avoid the surface entirely. They talk about the clouds, not the ground. The planet is telling you, clearly, where survival is possible and where it is not. Because here's the strangest contradiction Venus offers. Around 50 kilometers above the surface, temperatures can be in a range humans can manage, and pressure can be similar to Earth's. That layer is why people dream about balloons and floating labs, not boots on the ground. Even there, Venus refuses to be simple. High in the clouds, persistent dark streaks absorb ultraviolet light, and scientists still debate what they are and why they refuse to vanish. The upper atmosphere races around the planet, while the bottom sits under a heavy, suffocating blanket, like 2 worlds stacked on each other. So what would kill you first in those first 60 seconds after landing? The honest answer is whatever fails first. Venus is stacked constraints working together, not one hazard you can outsmart. Crushing pressure, furnace heat, CO2 you cannot breathe, heat transfer you cannot slow, chemistry attacking seals. This is why our exploration history reads like brief transmissions followed by silence. We can drop probes through the atmosphere, gather data, and watch them die. We can orbit and map with radar through clouds we can't see through in visible light, because seeing the surface doesn't mean surviving it. And yet we keep planning returns. NASA has selected missions like Da Vinci and Veritas to study how Venus became what it is. And ESA's Envision targets the early 2030s to map and probe the planet's evolution. Russia has discussed Venera D as a future return as well, because Venus is too important to ignore. Pull back from Venus now and watch it become beautiful again. A bright, evening star that looks calm from Earth. That's how it hides its true nature, by being close, familiar, and visually gentle. But the surface is still sitting under 93 bar of pressure and 467 degrees Celsius of heat, waiting for the next visitor to discover the same fact. On Venus, you get 60 seconds of systems fighting reality, and then silence.